Hello again, Mrs. Crayons, Honors Algebra 2 class, working on sequences and series. We haven't got to series yet. What comes next in that should actually say sequence. Question number 1, daily test. 9, 27, 45, 63. What do you think? There are a million or more sequence series tests. A lot of people consider these to be great questions that go on IQ tests. 15 sequences of numbers or letters. You've got 45 minutes. When finished, you will get your IQ. Of course, this is just for fun. This test is 2 spelled wrong. That should be T-O-O, short. And 2, T-O-O, one-sided to be 100% accurate. But you can take this 15 question test. Sequences of letters, numbers, all kinds of fun stuff. In Honors Algebra 2, we are in Chapter 9, and we're going to do one specific type of sequence today. We're at 9-2. I believe I'll post this on Wednesday, May 6th, 2020, right? We're working through Chapter 9, and there are lots of types of sequences, but there are actually 2 main types that we're going to work on. There's what we're doing today called the arithmetic sequence versus what we'll work on tomorrow, which is called a geometric sequence, all right? And you've looked at a lot of arithmetic sequences already in 9-1. A couple geometric sequences, and then there are all different other types of sequences that don't really get special names, okay? Versus any other type of sequence, all right? And sequences could have just numbers like we've been looking at. They could have variables, letters, symbols, anything, okay? But we're looking at one of the 2 main types versus just any other type of sequence, all right? An arithmetic sequence is a pretty basic sequence, okay? It has what's called a common difference. The difference between consecutive terms is a constant, all right? And whatever that difference is called a common difference, all right? An arithmetic sequence is the first type of sequence, the most basic kind of sequence, all right? So let's look at this. Number 1, is the sequence arithmetic? If so, find the common difference, all right, which is typically D, all right? All right, so you look at the sequence, figure out what's happening, all right? Is it going up or down by the same amount? If it is, it's an arithmetic. What's happening here looks like down by how much each time? 8, okay? So this is arithmetic, yes, and the common difference is -8. It's going down, okay? Let's see if we can write the recursive formula. Recursive formula, you always just start out with writing what the first term is. It's 48. And then what is a sub n? Well, you just take the previous term, a sub n minus 1, and subtract 8. That is your common difference, right? Now, what about the explicit formula? All right, well, here's how I figure it out, right? If it's just this basic arithmetic, it's going down by 8 every time, so it's -8 times n, okay? Then I need to do a little bit of calculation to figure out, well, how can I get up to the first term, which is 48? If I go -8 times 1, right, what do I need to add to get up to that first term of 48? Well, just 48 plus 8, I've got to add 56. All right? And that is your explicit formula. Right? But really all it asked for was this, common difference. Now, what about the next one? It's not going down, it's going up. First it's going up by 3, but then look, what's it going up by now? 4 Then it's going up by 5. So what will the next term be? A sub 1, 2, 3, 4, 5 would be 20. Right? Is it arithmetic? No, it's not going up by the same amount every time. It's going up by 1 more each time. That is not an arithmetic sequence. Okay? Yeah, and this is pronounced arithmetic as opposed to arithmetic, which is spelled the same but pronounced differently. All right? So, this is the first type of sequence we're going to look at, really just one of 2 major types of sequences. This is a very basic one, all right? The recursive formula always starts out with a sub 1 being whatever it is, the first value, like here, 48. Then for the recursive formula, you take the previous term, and in this case, you just add whatever d is. All right, if d is negative, it's just like minus 8 or something. D could be positive or negative, right? All right. Now, to get the explicit formula, okay, you can follow this formula, okay, which says take the first term and then add the common difference times the quantity n minus 1. Okay, but then you got to go ahead and simplify that and, you know, distribute, and then you got to combine these like terms, okay? I never use this formula. This is really not needed, okay? You've been figuring these out just like we did, all right? You figure out what the common difference is and you multiply by that and then figure out what you need to add or subtract on the end to get up to or down to that first term, okay? Now you can use this formula, but really, I don't think it's needed. I think you can figure it out on your own, okay, how to get that. All right, and let's do it. Now we're gonna do a whole bunch, all right? Write the explicit and the recursive formulas, and then we're gonna find a sub 43, the 43rd term in the sequence, okay? These are gonna be arithmetic sequences, going up or down by the same amount. Pretty basic sequences, all right? Number 1 looks like it's getting up. What is it going up by each time? 6, all right. So recursive formula always just lists the first term. All right, then a sub n equals the previous term, a sub n minus 1 plus 6, the common difference. All right. Then to get the explicit formula, the common difference is 6, so it's 6 times n. Okay. My first term is 0, so how do I get down to 0 when I plug in 1? 6 times 1 is 6 minus 6. There's my explicit formula, okay? Which is really, again, the very useful formula. And we're going to use it right now to find the 43rd term in this sequence, okay, without finding the first 42. All right, well, of course, we know the first 1, 2, 3, 4, 5. All right, so we're going to go 6 times 43 minus 6. And so plug that in, 6 times 43 minus 6. We get 252. All right. Nice. How about the next one? What's happening? All right, this is an arithmetic sequence because each time it's going down by the same amount. What's that amount? Looks like negative 6. Right. So the recursive formula lists the first term, 21. Then a sub n equals previous term minus 6. All right. Explicit formula. Right? Now you take the common difference, negative 6 times n. Okay. Ooh, then I've got to add quite a bit, huh, to get up to 21. Negative 6 times 1 is negative 6, and then I would need to add 27 to get up to 21. Okay. Check it out. Does it work for 2? Second term, negative 6 times 2, that's negative 12 plus 27. Yes, that's 15, right? Check. All right, so there's the explicit formula. We will use it now to find a sub 43. The 43rd term, that's negative 6 times 43. plus 27. What's that going to be? Negative 231. Okay. How about number 3? 1.3, 1.4, 1.5, 1.6. I know you know it'd be 1.7 next. So what's the common difference? Each time it's going up by 0.1. All right, so recursive formula. First term is 1.3. Then a sub n equals a sub n minus 1, the previous term, plus the common difference, 0.1. Right. Now the explicit term, you take 0.1, multiply it by n. Right, that's an n. And then to get up to 1.3, you need to add 1.2. Right. There we go. Explicit formula. Now let's use that to find the 43rd term. That is 0.1 times 4.3 plus 1.2. Okay. That's 4.3 plus 1.2, not 4.3, 43. Okay. Which is 4.3 plus 1.2. We get 5.5. Nice. Okay. 4. What's happening on this fourth one? Negative 2.1, negative 2.3, negative 2.5. This is going down by how much each time? Looks like negative 0.2. Right? So recursive formula lists the first term. Right? Then what? A sub n equals previous term minus 0.2. All right. Explicit formula. Take negative 0.2 times n. That would be 1. And then how do I get down to negative 2.1? Well, that's a minus 1.9. Okay. All right. Finally, we will get the 43rd term. Negative 0.2 times 43 minus 1.9. Let's see what that is. So put it in the calculator so we don't mess it up. We get negative 10.5. Okay. Arithmetic sequences. All right, now we're going to find the arithmetic mean a sub n given. All right. Well, you're given the previous term, 2 a sub n minus 1. Then you're given what's called the subsequent term, a sub n plus 1. That's 7. So you're given 7. Then we don't know the a sub n term. And sorry, you're given 2. Then we don't know the a sub n term. And then we're given 7. Okay. What's this middle term? Well, all you need to do is find the arithmetic mean, the average, right? Add them up and divide by 2. Right? That's not my D. Add them up and divide by 2. A sub n is 9 halves, 4.5. Okay. Now, then I'm asking us, well, then what would the common difference be? Well, you're going up by how much each time? 2 plus what is 4.5? 2.5. Right? There's common difference. Next one. Previous term's 29. Then what term's in the middle if you've got negative 11? Add them up. 29 plus negative 11, that's 29 minus 11 divided by 2. What do we get in the middle there? 29 plus negative 11 divided by 2. 18 divided by 2, 9, right? Okay. That's my a sub n. And what's happening? This is not going up. This was going up by 2.5. This is going down by how much? 20, looks like. There's common difference. All right. Next two, number 3 and 4, are really pretty much asking the same thing. Finding the term in the middle, the missing term. Okay. All you need to do is add these up and divide by 2. All right, to find the missing term. And what do we get there? Looks like it'll be negative 28.5. 28.5. Okay. Now what about this last one here? What do I do here? Now I have 3 missing terms. Okay. Which one should I get first? If this is the first term and this is the 5th term, I think we can get the middle term, which is the 3rd term, right? Just add these up and divide by 2. That's negative 20 divided by 2. That gives me negative 10. All right. Then we can add these 2 up. You get negative 8 divided by 2, negative 4. Right. Then you can add these 2 up and divide by 2 and get negative 16. Or you could figure out what's the common difference on this. These are all going down by 6. So we could have just done negative 10 minus 6. But we'll get this one first. Okay, then you can get this one second or this one second. Doesn't really matter. Okay. Last one we're going to do is a little story problem. All right, so if we read through this, it says each year a volunteer organization expects to add 5 more people to the number of shut-ins for whom the group provides home maintenance services. Oh, maybe now everyone almost is a shut-in. This year, the organization provides a service for 32 people. Okay, so that is your first term. All right, 32. All right, then adds 5 more people. All right, every year. All right, so what about the second year? What would that be? Plus 5, 37, etc. All right, write a recursive formula. All right. Well, we start out with the first term for the first year. That's 32 people. Then a sub n equals the previous term, and you're adding 5. This is just your common difference. All right. Write the first 5 terms in the sequence. Well, we have the first 2, then we add 5, we're at 42, and then we're at 47, and then we're at 52. All right. Part B. Now how about the explicit formula? What's that? A sub n equals 5n. Okay. Now 5 times 1 is 5. What do I need to add to get up to 32? 27. Yep. There we go. A sub n equals 5n plus 27. All right, lastly, how many people would the organization expect to serve in the 100th year? What's the 100th term? Well, it's 5 times 100 plus 27. That's 527 people. All right. These are all arithmetic sequences. A sequence of numbers that go up by or down by the same amount every term. Okay. Tomorrow we'll look at geometric sequences, all right, the other main type, all right, versus all the other types out there, all right. Have a good day. We will hopefully see you soon.